Welcome to the pre-calculus skill video for skill number 1. I can simplify expressions involving integer exponents, including expressions involving scientific notation. And this video lesson challenge question is, the map featured below is of what city? We'll start our notes on page 1A, where I have listed the 7 properties of exponents. The first property states that if you have a number, for example 7, raised to a power, we'll say 3, and we multiply that by another number that is the same value, so it also is a 7, raised to the 5th, what we can do is combine our exponents so that we have 7 raised to the 3 plus 5, or 7 to the 8th. Property number 2 is of a similar scenario, however we are dividing. So if we have u to the m over u to the n, that is the same thing as u to the m minus n. And I've shown an example here, x to the 5th divided by x squared. We can simplify to x to the 5 minus 2, which is x to the 3rd. The next property of exponents is the u to the 0. Any number raised to the 0th power is equal to 1. For example, 5 to the 0 is 1, 3 to the 0 is 1, etc. 2 to the 0 is 1. Continuing with property 4, what we have is the case where if you have some number and we raise it to a negative exponent, that's the same as writing 1 over that number to the positive exponent. So I've given an example here and then also right here. Property 5 is if you have two numbers that are being multiplied and that quantity is being raised to a power, what we can do is distribute the power in. So u to the m times v to the m. And I've shown an example here. We distributed the 5 in, we get 2 to the 5th, and the 5 in for the z, and we get z to the 5th. And then this can be simplified further to 32z to the 5th. Number 6 is an exponent raised to an exponent. So if we have x squared and that quantity is raised to the 3rd power, we can multiply our two exponents. So x to the 2 times 3, which simplifies to x to the 6th. And then the final property of exponents is u over v, and that division is raised to a power. And we can do the same thing of distributing the power in, so we get u to the m over v to the m. And I've written an example here. 2 over x all raised to the 3rd power gives us 2 to the 3rd over x to the 3rd, which further simplifies to 8 over x to the 3rd. Example 1 and 2 are demonstrations of the sort of question I would anticipate you seeing on a skill test or coming up throughout the course of your math studies. Example 1, simplify 2x squared y quantity to the 3rd power. So in the first step, what I did was distribute the 3 in using property 5, so we got the 3, 3, 3, and then I simplified it. 2 to the 3rd is 8, x to the 2 to the 3rd is x to the 6th, and y to the 3rd is just y to the 3rd. This is a low-level example. Example 2 is a little bit more challenging. What we have is 6x to the 7th y to the negative 2 all over 2x squared y to the 4th. In these sorts of problems, I like to take the problem and break it into its like components. So I grouped all the numbers. 6 over 2 is 3. I grouped all the x's. X to the 7th over x squared is x to the 7 minus 2, and y to the negative 2 over y to the 4th is y to the negative 2 minus 4. and then I simplified each piece. 3 is 3, the x becomes x to the 5th, and the y goes to y to the negative 6th. And then in the final step, we got rid of the negative exponent by moving the y to the denominator. If for some reason we had a case where we had, let's say, 3 over x to the negative 4th, we could simplify that to be 3x to the 4th. So a negative exponent allows us to make it positive by taking the reciprocal. A simplified exponential expression will, in my classroom, always have a positive exponent. Moving to the second part of the skill is dealing with scientific notation. And scientific notation is a common method used for writing very large or very small numbers. And it's written in the form of c times 10 to the m, where c is a number between 1 and 10, and m is an integer. This funny looking symbol notation here says that m is in the set of integers. So m is an element of the integers. For example, we could have 2.3 times 10 to the 5th, or we could have 1.0 times 10 to the negative 3. And on the final page of our notes, I gave 4 examples of standard form and scientific notation. So this 93 million, what you could do is you could say there was a decimal here, and we moved 1, 2, 3, 4, 5, 6, 7 spots. And that's why we have 9.3 times 10 to the 7th. In the second example, our decimal moved 1, 2 spots. So we have 10 squared. If we're moving to the right, we want to consider negative exponents. So in the third example, we moved 1, 2, 3, 4, 5 units to the, or 5 placeholders to the right. So we get the answer 4.9 times 10 to the negative 5th. And in the final example, we moved 1, 2, 3, 4, 5, 6, 7. 7 units, giving us 10 to the negative 7th. The sign out front, positive or negative, has no impact on the exponent in scientific notation. Generally, the way you could think about it is large numbers, numbers greater than 1 will have a positive exponent, and small numbers, numbers between 0 and 1, will have the negative exponent. Below I've given an example that combines what we've learned about exponents with scientific notation. So, simplify 370,000 times 4.5 billion divided by 12,000. And this is the sort of activity where you could plug it into a calculator. However, this skill test will be calculator free, or largely calculator free. So what we want to do is perhaps write it into scientific notation. So the first thing I did was I took 370,000 and wrote it as 3.7 times 10 to the 5th. And then I took 4.5 billion and wrote it as 4.5 times 10 to the 9th. And then I took 12,000 and wrote it as 1.2 times 10 to the 4th. From there, I used properties of exponents. So in this first step, I grouped my numbers together, 3.7, 4.5, and 1.2, and I multiplied that by our numbers of a common base with exponents. 10 to the 5th times 10 to the 9th over 10 to the 4th. I simplified the first piece, and then I simplified the second piece using properties 1 and 2 of exponents. At this point, we have an answer. However, this answer is not in standard form or in scientific notation. So in order to make it in scientific notation, it has to have a number between 1 and 10. And what we have is we have 13. So if we want to make that between 1 and 10, we're going to move our unit, our decimal, one spot to the left, giving us 1.3875, and since we moved it 1 unit to the left, 10 to the 10th became 10 to the 11th. Which if we write in standard form, once I correct my mistake here, we have a very large number of 138,750,000,000. Alright, this concludes the video for skill number 1. I can simplify expressions involving integer exponents, including expressions involving scientific notation. And for those who are curious, the city map is the city of Paris, France in 1900. Thank you.